graph the solution set of each system of inequalities. We have y is greater than 5x minus 4, and y is less than negative 2x plus 3. Alright, so I will graph the first inequality in blue. So notice it is in slope-intercept form. And so I know that m is 5, and the y-intercept is 0, negative 4. Let's just use a standard scale on each axis. So let's see. The y-intercept is negative 4. I will plot that point. And now using that the slope is 5, I will let the line rise 5 and run 1. Rise 5 and run 1. Now we'll graph the line. And since it's a greater than inequality, I will use a dotted or dashed line. Alright, the line does not pass through the origin, so let me test the origin. So then I would have 0 is this greater than 5 times 0 minus 4. Going through the arithmetic on the right, 5 times 0 is 0, subtract 4 is negative 4. Is 0 greater than negative 4? Yes, it is. So 0, 0 is a solution of that inequality, and so we would shade the region containing 0, 0. And I put my little marks there that I would shade above that blue line. I'll work in red for the second line. Notice that this is also in slope-intercept form with slope equal to negative 2 and y-intercept of 0, 3. So I'll plot the point 0, 3, and then the slope is negative 2, so let the line fall 2, run 1, fall 2, run 1 to get a couple of points. Again, since it's a strictly less than inequality, we will use a dotted or dashed line to mark this boundary. We need to decide where to shade, so again I will test the origin. Since the line does not pass through the origin, is 0 less than negative 2 times 0 plus 3. So going through the arithmetic on the right, negative 2 times 0 is 0, plus 3 is 3. Is 0 less than 3? Yes, it is. So for that red line, I would shade below it, since 0, 0 was also a solution. So now I have to decide where to actually shade. We shade the region that satisfies both inequalities simultaneously. So I will shade the region that satisfies the blue and red arrows, and so I will shade in purple this entire region. Here we have a second system. We have 3x minus 4y is less than or equal to 12, and y is greater than 2. So working again in blue for the first inequality, and again use just a standard scale on the axes. Three x minus 4y is less than or equal to 12. So since that's in that standard form, I'm going to use intercepts here. Let's find the x-intercept, letting y equal 0. So then 3x minus 4 times 0 is equal to 12. So 3x equals 12, and dividing through by 3, x equals 4. So our x-intercept is 4, 0. The y-intercept, we will let x equal 0. 3 times 0 minus 4y equals 12. So negative 4y equals 12. Dividing through by negative 4, y equals negative 3. And so we have 0, negative 3. So 4, 0, 0, negative 3. I will draw the solid line through those points. What should we test? Well, the line doesn't go through the origin. Let's test the origin. Testing 0, 0 is 3 times 0 minus 4 times 0 less than or equal to 12. Going through the arithmetic on the left, we get 0 subtract 0, which is 0. Is that less than or equal to 12? Yes, it is. So we would shade, for that individual inequality, we would shade the region containing 0, 0. Y is greater than 2. So recall that when you just see y or x, and just one of the variables and a number, recall that that's either a horizontal or vertical line. This is a horizontal. All right, when we see y equals a number, that's a horizontal line. And so I will draw the horizontal line at y equals 2. And I will use a dotted line to mark this boundary, since it's a strictly greater than inequality. Oops. A little low. Now, where is y greater than 2? Y is greater than 2 above that boundary. And so now we take both of those inequalities into account and we decide where to shade. We must satisfy both of these boundaries and both of these shadings. So I would shade this region above, above.